Okay, after connecting to the Wi-Fi, step 5 is connecting to the IFTTT. IFTTT is the website we're using. So while making the applet, we were provided with a link. So we will use that link to send the trigger. In this link, you can see there's JSON. So we have to remove this because we are using just singles. We are not using JSON. Okay, we must change this event with our trigger. So earlier, while making the applet, we used the fire detection as our trigger. So we'll replace event with the fire detection. Previously, while connecting to the Wi-Fi, we included this Wi-Fi.h header file. This header file also includes the Wi-Fi client class, which we can use to access server as a client. We've defined the host and private key in the variables. The send event function will carry out all the communication with the website. Whenever the function is called, it will write on serial port that it's connecting to the host from the website we have provided earlier. The Wi-Fi client is a class. We are making its object client. The Wi-Fi client class is specifically the Wi-Fi.h header file. This client object has multiple functions to communicate with the website, and port 80, HTTP port is equals to 80. The HTTP port is set to 80 because the HTTP communication is mostly carried out by port 80. That's why it's set to 80. Client.connect. The function connects to the host. We provide host and port which you want to connect. So port is 80 and host is the IFTTT website. The function returns true or false based on the connection was successful or not. So if the connection was successful, it will return true, and this condition will be skipped. If it returns false, this condition will be executed and it will print connection failed and return end. Returns means the function will end over here. It will not further execute. Okay, if the connection was successful, we'll move on to building the trigger address. Here's the trigger address. We're building the trigger address. What we are doing here, we define a string, then we are just adding words to this string, URL string. First we added trigger, then we added event what we received over here, then we added with key, and then a private key which we defined in the beginning. So here you can see the this web address is taken from here, like this was the host, and this trigger, event, JSON was skipped, with key, and the private key. So here you can see we added trigger, then event, then with key, and then the private key. So we are just building this web address which we want to send trigger to. Okay, so this whole address, trigger, event, with key, and the private key, whole this address is built over here by adding it to the URL. So now URL variable have all this trigger, event, with key, and private key. So now what we are doing is using the client object to send data to the website. So we are just giving it command get data from the URL this, which is defined over here. This whole thing is the URL. So get data from the URL using the protocol HTTP 1.1. Then we send another command. So who is the host of this URL? The host of the URL is host. And the host is a variable, string variable, which is defined earlier in the when we were defining the private key and host. So this variable is stored. It have this value makers.iftt.com. This is the host which is stored in this. Then we send the host, and then we send, after the completing the process, should close the connection. These are the commands we are sending to the web server. After sending the commands, we'll use a while loop to wait for the server to respond. The while loop will execute until this client is connected to the server, and this condition will check whether the data is available to read or not. If data is available, it will read the data until it encounters slash r on the end of a line carriage returned character, and all that readed string is stored into the line variable, and this will be printed to the CL monitor. If there's nothing to read available, then it will just wait for 50 milliseconds, and then again try to check whether there's anything available to read or not. After the connection is terminated, the while loop will also be terminated, and this block of code will be executed. What it will do is print nothing on the CL monitor, give us line space, then it will print closing connection, and then it will stop the connection. This is just a measure. Connection was already stopped, but in case there's anything, it is just stop the connection completely. Okay, this is an example of function header. So why we use this? See, when a compiler compiles, it comes from top to bottom. Suppose this doesn't exist. Okay, over here. So compiler compiles and comes top to bottom. It comes like down this like this. Okay. So if this function, we have defined this function after the while loop. So if this function is called anywhere in the loop, so the compiler will prompt us an error that this function does not exist, because when it compiles from top to bottom, it never reached over here, so it don't know that this function exists. So this practice is done to tell the compiler that this function exists somewhere. Just trust us that it exists. So as this function is defined below the while loop, the loop function is up here, and this function is defined over here. If we want compiler to not generate an error in case this function is called in the loop, so we add this statement over here. This tells the compiler that this function exists. So whenever it is called in the while loop, it doesn't prompt us that it's an error or not defined. And when it reaches here, so we get the function. Okay, so this was our old loop, and if we were just reading the sensor and writing the LED, it was for test. So now we have defined our functions for communication with the server. So we will add this is the new loop, void loop. Now here you can see that we are reading the sensor, and if sensor says yes, I detect fire, so output is 1. So we'll write on the CL communication that fire is detected. It will be on CL prompt, CL terminal. Then we'll write the LED high. So the red LED which is connected to the pin will turn on, telling that the fire is detected. And there is a send event function. This is a function we defined, send event, which will communicate with the server. So what we are sending it the fire detection. So this is important because this should be same as we have defined while making the applet. So in applet we said fire detection is our trigger event name. This was our trigger also. So the event detection, fire detection should be the same as we have defined over here. Otherwise, it will not work. After the sending event, this function is called. All the process that connecting to the server and reading data and writing to the prompt, everything happens, and communication close and exists. It exists, and loop start again.